Okay, so we're on the back side of the first page. We're on question number 13. Before we even start this thing, let's go to number 14. There's a typo. Notice that the second parenthesis has a squared and a squared. That doesn't make sense. That should have been a b squared. So please make sure that you change that second a in the second parentheses to a b, or else it won't make sense. Anyways, go back up here, number 13. It says factor. And the very first type of factoring that we learned was to pull out the GCF. So we need to look at 42 and 70 and see what we could pull out. Okay, so I'm going to kind of pretend that I'm a student and I'm like, I don't really know 42 and 70, but I do know that they're both even numbers. So I could pull out what? I could pull out a 2, right? So I could pull out a 2, and I could also pull out, there's x's and y's in both, so 2xy. Now let's see what would happen if I pulled out a 2xy. In other words, 2 times what would give me 42? That would be a 21, right? And then the x times what would give me an x squared? That would just be a regular x. And then 2 times what would give me a negative 70? 2 times negative 35 would give me a negative 70. X times what gives me x? X times 1, which means I don't need anything. Y times what would give me a y to the third? That will be a y squared. Now, a lot of us would think that we're done, but the problem is that was not the GCF. The 2 is not the greatest multiple. And you could clearly tell that because if you look at the inside right here, 21 and 35, these are both divisible by what? 7. By 7. So you could pull out another multiple of 7. So if we pull out the multiple of 7, that really is 7 times 2, which would be 14 out there, right? So let's do this. I'm going to put the 2xy right here, and I'm going to actually pull out another 7, and I'm going to put a multiplication right there, all right? And when I pull out that 7, on the inside, I will have 3x and minus 5y squared. Agreed? Yeah. And then the 2 and the 7, I'm going to put them together, and that'll be my final answer, 14xy, open parenthesis, 3x minus 5y squared, close parenthesis. That is it, ladies and gentlemen. Is that the easiest way to do it? Heck no. The easier way of doing it is to really find the GCF right here and started right from the beginning. 14 works into both of those, right? 14. So you'd have a 14xy, and you think 14 times what gets you 21? 14 times what gets you 42? 14 times 3 gets you 42. So you'd get directly to this answer if you would have pulled out the GCF first. Does that explanation help you guys? Okay, let's go to number 14. This one's pretty easy. Simplify this using rules of exponents. All you got to remember is that when you're multiplying two terms with the same base, you add the exponents. So the a to the 7th times a to the 2nd, add those together, you get a to the 9th. So let me write a to the 9th. And then how about the b to the 7th times b to the 2nd? That's also going to be b to the 9th. And that is your answer, guys. A to the 9th, b to the 9th. Ta-da! Easy. Moving on, number 15. Solving this equation. Yes, absolutely. You could get rid of things by doing the opposite, and we all know that the opposite of a square is a square root. So let's apply a square root on both sides of the equation. You will end up with w minus 9, no more square, equals plus or minus 4. That's right. The square root of 16 is 4, but you have to put a plus or minus right in front of your answer. Now, let's get rid of that minus 9 by doing a plus 9. And what you do to one side, you must do to the other. Now, this is a little bit more complicated to add a 9 with a plus or minus 4, because that really means that you're going to take the 9 and go plus 4, and then 9 minus 4. So let's actually write it out from side to side. In other words, w equals that positive 9 with the plus or minus 4 right after it. And now let's do both situations, the 9 plus 4 and also the 9 minus 4. Giving us two answers of 13 and also of 5. So the two answers of number 15 are the answers 13 and 5. Going way back in time, 16a, we want to graph, oh no, that's not way back in time, that's parabolas, that's easy. We want to graph that standard form parabola, or you could look at it as vertex form. Now, if you want to look at it in standard form, that would be ax squared plus bx plus c And the b value, notice that there is no b value, there is no bx term. So that means that your b value is 0. So you could use the vertex formula, plug in 0 for b and -1 for a and find your vertex or your vertex x value. But the easier way of doing it would be to put parentheses around the x. That way you could see this in vertex form. What's vertex form? It's y equals a parenthesis x minus h close parenthesis squared plus k. Should probably do plus k in blue or red, I don't know. Anyway, that's the vertex form equation. So if we rewrite our original equation to our vertex form equation, it's going to be y equals -1, open parenthesis, x minus nothing squared plus k, which is plus 2. So we could clearly see that our vertex is the coordinate 0, 2. So let's go to 0, 2, which is right here. We're going to draw our axis of symmetry right through it. And we can use the pattern 1, 1, 2, 4, 3, 9. We don't have to modify any pattern because that a value is -1. So using the pattern, that's the pattern from the vertex. So when we go 1 over, 1 down, let's put a dot right there. Then go back to the vertex, go 2 over, 4 down, 1, 2, 3, 4, put a dot right there. Go back to the vertex, 3 over, 1, 2, 3, 9 down, that's 7, 8, 9, you'll be right there. If you count carefully, you'll get there. If you don't, you might go off the graph. And then map those coordinates over to the other side. Boom, boom, boom. Connect the dots. We have our parabola that opens down with the pattern 1, 1, 2, 4, 3, 9. Or you could have used a table if you wanted to. Only other things to answer here are the domain. That's x equals all real numbers. The range is y is less than or equal to, because the parabola opens down, less than or equal to the y value of your vertex. And also the y-intercept, that's simply where it crosses the y-axis, in this case at the value of 2. And also your axis of symmetry. That's going to be the equation x equals the x value of your vertex, which is 0. Moving on. Oh yeah, by the way, down here, we were supposed to fill all that in, sorry. Okay, so just make sure you transfer the answers down to here. Axis of symmetry is x equals 0. Domain, x equals all real numbers. Range, y is less than or equal to 2. Number 17, state the discriminant. In order for you to state the discriminant, you need to have everything on one side set it equal to 0, right? Because technically it's like doing the quadratic formula. So let's first subtract 15 on both sides. We're going to have the new quadratic trinomial equation 4x squared plus 7x minus 15 equals 0. And your a value is 4, your b value is 7, your c value is -15. Now the quadratic formula itself is -b plus or minus the square root of b squared minus 4ac divided by 2a. But you don't have to do the whole thing. All they want you to do is to find the discriminant, the b squared minus 4ac. Okay, so if we wanted to, we could just find the b squared minus 4 times a times c. And that's exactly what I'm going to do. Plug in your b value of 7 right there, a value of 4 right there, and the c value of -15 right there. And I will use a calculator. Well, you could, if you want to, use a calculator to figure it out. So type it in exactly the way it is, especially on a Casio. It does it very nicely. So if you type it in correctly, you will get the answer 289. Now, since we're not solving, they just want us to find the discriminant and then determine the number of answers we actually have. Because this is a positive discriminant value, we will be able to take the square root of 289. It's not like it's an imaginary number, right? It's a positive number. Whenever your discriminant is positive, you're going to get 2 real solutions. Okay, so they're asking for the discriminant. Here it is. That's a discriminant. And how many answers do we get? We get 2 real solutions. Let's do the same for number 18. Let's first add 30 to both sides. And we're going to have the new equation that reads 2x squared plus 15x plus 30 equals 0. Again, identifying a, b, and c. So now that we know the a, the b, and the c, we could plug it into the discriminant b squared minus 4ac. b squared minus 4 times a times c. That is 15 for b. A value is 2. C value is 30. Again, calculator time would be good. Could somebody do this for me? 15 squared minus 4 times 2 times 30. Let me try this. I think it's 225 minus 8 minus 240. Minus 240. That's going to be a negative 15, I believe. So your discriminant value is negative 15. In other words, if you were doing the quadratic formula inside the square root, you'd end up with the negative 15, which means that you couldn't continue on, because if you do the square root of negative 15, it's no solution. It's an imaginary number. So because the discriminant is negative, there are no real solutions. So negative 15 is a discriminant, and that means that there's no real solution. I mean, that makes total sense, guys, because if the value inside your square root in the quadratic formula is negative, you can't do the square root of negative 15. That's an imaginary number. So you will not get real answers. What does that mean visually? If you were to graph this parabola, ax squared or 2x squared plus 15x plus 30, that means that it would open up, it's pretty narrow, and it will not cross the x-axis. It does not touch the x-axis. That parabola is above the x-axis. But right here they're asking you, find the discriminant. We found out it's negative 15. Because it's negative, you have no real solutions. Now, what if I would have done the discriminant and that discriminant would have been 0? Then the square root of 0 is 0, and it doesn't matter if you add 0 or subtract 0. It does not change your answer, which means that if your discriminant is 0, you only get one solution. Okay, and I guess that's what's going to happen on this third one, since we did 3 examples. Plus 9, we have 4x squared minus 12x plus 9 equals 0. Let's figure out the discriminant. B squared minus 4 times a times c. Again, this is what's on the inside of the root in the quadratic formula. So if we go negative 12 for the b values, a value of 4, c value of 9, and work this out, we're going to get negative 12 squared is 144, and then this times this is 16 times 9 is also 144. So you really have 144 take away 144, which means that the value inside our discriminant is 0. So if you did continue on with the quadratic formula, adding 0, subtracting 0 doesn't make a difference. So right here they're saying, what's the discriminant? The discriminant is 0. And how many solutions do we get? We get one real solution because the discriminant is 0. I hope this makes sense to you guys. Number 20, on the test it'll say solve each equation by factoring. Check your solution, but there are other ways of solving this equation. Do you guys want to use square roots to solve the equation, or do you guys want to actually factor? Square. You guys want to try the square roots? All right, so let's pretend, because there's only one x, there's no other x's, I am going to isolate the x by itself on one side. In other words, I want to get rid of this multiplication of 9. And how do I get rid of the multiplication of 9? By doing the opposite of multiplying by 9, which is dividing by 9. Well, you do to one side, you do to the other side. Now, unfortunately, it's not 63 divided by 9. That would have been nice. 63 divided by 9 is 7, but it's not. It's 64 divided by 9, so I can't do it. Let me just rewrite what I have. I have x squared equals 64 over 9, and I'm now going to get rid of the square by applying the opposite of a square, which is a square root. And whatever you do to one side, you do to the other side. That way you end up with x equals, but when you apply a square root in an equation, you have to put a plus or minus right in front of your answer. So up on top, you're going to end up with the square root of 64. On the bottom, you're going to end up with the square root of 9 because this square root splits to both the top and the bottom. There it is. So the square root of 64 ends up being the beautiful, nice number 8. On the bottom, 3. So your answer is x equals plus or minus 8 over 3, 8 thirds. That's your answer. You could have moved everything to one side and factored, split, and solved, but you'd get the same exact thing, 8 thirds. I think this is the easiest way of doing it. I hope you guys remember that. Even though it says factor, to solve, you could just get the x squared by itself and then apply a square root and then split that square root. This next one is really easy. However, it's actually difficult on the test because you end up with multiple terms, multiple answers, and you might make a mistake. I actually made a mistake when I practiced on the final exam itself. So be very careful when you do this. I wouldn't even look at the multiple choice answers till you're done doing it. So let's distribute. What's negative 7k times negative 3k squared? What's that?
21.
Positive 21
K cubed.
k to the third. That's right, k cubed. Okay, how about negative 7k times 2k?
Negative 14k squared.
Negative 14k squared. Okay, negative 7k times negative 9. Positive 63 with a k. All right, so now let's distribute the 4. 4 times negative 3k squared, that's negative 12k squared. And notice I'm not going to put negative 12k squared right here. I could, but it's easier if I write that negative 12k squared right below the other negative 14k squared. That way it'll be ready and easy to combine. And then let's distribute 4 times 2k. That's going to be 8k. And notice that I wrote it right below the 63k. And then 4 times negative 9, that's going to be a negative 36. And I write that at the very end. Now it's a lot easier to combine like terms. I just combine these guys right here, and I will get a negative 26k squared. And then I could combine these guys right here. That'll be a positive 71k, and bring down that minus 36. And also don't forget about the 21k to the third in the front. So this is the answer, ladies and gentlemen. But let me tell you guys, when I did this, I got the right answer. But when I started looking at my multiple choice answers, I ended up picking the wrong one because there was one that looks exactly like it, but instead of a minus, it's a plus. So be very careful when you're checking your answers on the multiple choice. Moving on, number 22, you want to find the coordinate of the vertex of the graph of this function. Now, if you look at it in vertex form, what is vertex form? It's y equals a parentheses x minus h squared plus k. It's really easy to see your vertex. That's simply the value hk, thinking opposite on h and taking k for what it is. However, we don't see parentheses here, so let's put parentheses around that single x. If you put parentheses right around that single x right there, you will have your vertex form equation y equals negative 2 parenthesis x minus h. You don't have a minus h, which would mean minus 0, and it is squared plus k, which happens to be the minus 5. Is everybody with me? So does everybody understand how I changed this to look like this? Yes, I put parentheses around the x. There is no h, so it's just minus 0. That's right. So what's your vertex now that you see it? What's your vertex? 0 and negative 5. Piece of cake. Easy peasy. All right. So we're on question 23 right here. It says factor completely. It's super easy to factor this quadratic trinomial because the a value is 1. Okay, the a value is 1. So you could simply jump right into parenthesis, 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 b, b, and think what times what is 36 that if you add together is negative 12. If you don't see it, you might want to make a list. How could you get 36? 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't work, 6 times 6. And when you start combining, that gives you 37, that gives you 20. You want this middle value b, right? So, and the only pair of numbers that works is the 6 plus 6. That'll give you 12, but we want it to be a negative 12. So we know we have the right numbers, we just have the wrong signs. So change the signs on both of these, and that's what you plug in. B minus 6 times b minus 6. That's it, we're done. The only other thing that I might warn you here or tell you to look out for is the multiple choice might write it as, because it's the same binomial written 2 times, they might write it as b minus 6 to the second power. I'm not sure if they write it like this or like this. Either one's correct, but you need to be able to identify that on the multiple choice test. Moving on to this one, says factor completely. This one's more appropriate for those instructions of factoring completely because you have to apply 2 different factoring methods. One method is pulling out the GCF. What's in common? There's a 7 in both of them. So we're going to pull out that 7, and what would we have left on the inside? We're going to have a v squared minus 9. Now, I hope we remember that on the inside we have a difference of 2 squares, right? Or you could even think of it as what times what is negative 9, that if you combine together is the middle term, but there is no middle term, which means nothing, right? So what times what's negative 9 that if you combine together is nothing? Help me out here, guys.
What times what
See, my idea, or what I'm doing here is putting the v and factoring further on the inside. What times what is negative 9, that if you combine together is your middle value b, which there is no middle value b, which means nothing, right? What times what is negative 9, that if you combine together is nothing?
1.
9, positive 3.
Positive 3 and negative 3, guys, right? So, you guys are scaring me. Positive 3 and negative 3. What times what is negative 9, that if you combine together is nothing? I don't know. Maybe you guys aren't seeing this. Maybe if I did this, v squared plus there is no regular v minus 9, is that better? Where you could see the a value of 1, the b value of 0, and the c value of negative 9? But the idea is, what times what is the last one, that if you combine together is the middle one? Right? What times what is negative 9, that if you combine together is nothing? Well, that's a positive 3 times a negative 3. It's just factoring. But you do need that 7 out in the front, and that's your final factored form on that one. So on the test, you will have one where you have to pull out the GCF, which is just a number, and then you're going to be able to continue factoring on the inside, and it's most likely going to be a difference of 2 squares the way it is right here. Number 25, determine which sequence is arithmetic, geometric, or neither. Okay, well, we need to understand that arithmetic sequences, arithmetic, have a common difference. Okay, so what does that mean, common difference? If you take any number and subtract the number before it, that answer should be common in between all the numbers. Okay, so if I go 8 take away 32, what's 8 take away 32, guys? Well, it doesn't even matter. If I go 32 take away 128, is that going to be the same as 8 take away 32? Heck no. So like 8 take away 32 on a calculator, that's negative 24. But if I do 32 take away 128, that's definitely not negative 24, that's negative 96. So there's definitely no common difference, which means it's definitely not arithmetic. So now we need to move on and check if it's geometric. So what does geometric mean? That one has a common ratio. Common ratio R. Now, how do we do a common ratio? Well, you have to take a number and divide it by the previous number and then get an answer and see if that answer is consistent between all of the numbers. So if you take on the Casio calculator 8 divided by 32, hit equal, and it will give you the answer 1/4. Okay? And that makes total sense. 8 divided by 32, you could reduce that by 8 and you'll get 1/4. Now, the question is, does that happen between all the terms? If I do 32 divided by 128, 32 divided by 128 on the Casio calculator, hit equal, it does give you 1/4, right? And if you do the next one, let's say the 128 divided by 512. 128 divided by 512 on the Casio calculator, 128 divided by 512. Hit equal, and yes, it also gives me 1/4. So absolutely there's a common ratio on all of them, so this is for sure geometric. It's just asking, is it geometric, is it arithmetic, or is it neither? Now, if I wouldn't have gotten a 1/4 on all of the terms, between all the terms, by dividing, if I would have got a 1/3 here, a 1/4 here, a 1/4 there, but when I did these, if I got a 1/3, then it's not geometric. It has to be common between all the terms. Then you would say neither if that would happen. So I hope we understand that. That is on the final. Number 26, the last one on this page. It's graphing, and it's pretty easy because it's in vertex form. All you do to identify your vertex, first step is identifying your vertex, is to identify H and K. You think opposite on H, you take K for what it is. So what's your vertex?
Negative 3, negative 5.
Easy peasy. So let's go to negative 3 on the X, negative 5 on the Y, put a dot right there. Second step is to draw your axis of symmetry. And we might as well state the equation. X equals what? What's the axis of symmetry equation?
Negative 3.
X equals the X value of your vertex, which is negative 3. They might ask you that. I think they will ask you that on one of the questions. Let's draw our axis of symmetry. It's that vertical line going right through that vertex, the X equals negative 3 line. Anyway, we need more coordinates. So I could, if I wanted to, use an XY table right? I could plug in some numbers for x, work it all out, get out answers for y, or I could use the pattern 1, 1, 2, 4, 3, 9, but I would have to modify it. So it's totally up to you guys. If I wanted to use 1, 1, 2, 4, 3, 9, I would have to modify these numbers, the 1 and the 4 and the 9, I have to modify those by what?
2.
By 2. The a value is 2. This pattern is good for the a value of 1. But if you have the a value of 2, you need to modify 1, 4, and 9. You need to modify those numbers by 2. So let me show that. By 2, by 2, by 2. So my new outputs are 2, 8, and 18. So this is what I call modifying. Multiplying everything by 2. And what's my new pattern? My new pattern is 1, 2 instead of 1, 1. It's 2, 8 instead of 2, 4. It's 3, 18 instead of 3, 9. Now we do know that this is a positive a value, which means it's opening up. So if I want to use a pattern, it's going to go 1 over 2 up. So 1 over from the vertex, 2 up, put a dot right there. Go back to the vertex and go 2 over 8 up. So 1, 2, 5, 6, 7, 8 would be right there. Put a dot there. And of course, 3, 18, 3, 18, you're going to be way off the graph, right? So let's just map those blue dots over to the other side. Nice and easy. Connect your dots. And you have your parabola. Another easy way of finding or identifying the correct parabola on your multiple choice final is, of course, the vertex. You'll be able to find that, but there's going to be a parabola that's a little bit wider and a parabola that's a little bit narrower. So you could get away even without doing the pattern just by checking one point. What would an easy point be? To check your y-intercept, right? But even right here, I don't think you'll be able to see the y-intercept, but I think on the test you could check the y-intercept. How do you find the y-intercept? You set x equal to 0 and solve. That's right. So you really have, let's do this in our head, 0 plus 3, that's 3, and 3 squared, that's 9, and 9 times 2 is 18, and 18 take away 5, that would be 13. So in this case, it really didn't help us. The y-intercept is 13, which means that it crosses somewhere way up here, even off the screen. So it didn't help us here, but I think on the test you will be able to calculate those y-intercept values, and you'll be able to help identify the correct parabola with that. Now you could have also used the XY table. All you have to do is plug in values and pull out answers. So if, for example, I would have plugged in a -1 right in there, -1, let me actually write that down. -1, that'd be -1 plus 3, that's 2. 2 squared is 4. 4 times 2 is 8. 8 take away 5 is 3. So for my input of -1, I get the output of 3, and that's an actual coordinate. Check it out, -1, 3, boom. So you could get these same exact blue dots using an XY table if you don't want to modify your pattern. It's totally up to you. This video is ridiculously long. I'm going to stop right here, and we'll pick up the next video with question 27.